This is 7.4, comparing linear and nonlinear functions. So a nonlinear function does not have a constant rate of change. That means it is not a straight line. A rate of change refers to slope, so that means the slope is not the same throughout the whole line. In contrast, linear functions do have a constant rate of change and are straight lines. So if I have two different graphs here, the first one is linear, it's a straight line. The second one is a curved line, and it is nonlinear. So the slope between these 2 points is not the same for every part between them. So we're going to look at a couple tables and see if they represent a linear or nonlinear function. So I have this table, and to see if it's linear or nonlinear, I think, does it have a constant rate of change? So I could use my formula for slope, and I can find the slope between 2 and 4, 4 and 6, and 6 and 8. Or I can look at my x's, and I think my x's increase by 2 each time. That's steady. Then I look at y's. Y's decrease by 2 each time. So it has a constant rate of change because they increase by the same amount or decrease by the same amount each time. So we could say x and y have the same change between each point, so it is a linear function. This does not mean that x and y change the same as each other, but throughout the function, x is changed by the same amount and y is changed by the same amount. I have another function here, and if I look at my x's, the difference between each one is 2. So x's increase by 2 each time. When I look at y's, I see that y's do not increase by the same amount each time. First it increases by 12, then 20, then 28. So this is not linear because there is no constant rate of change. Now we're going to look at equations and see if they are linear or nonlinear functions. I have y equals 3 times x plus 2. When I distribute the x, I get y equals 3x plus 6. We can write this in slope-intercept form, and it has a constant rate of change, therefore it is linear. If we have y equals 2 over x, I cannot write this in slope-intercept form. It kind of looks like it, but I'll get 2 times 1 over x, and that's not linear. So it does not have a constant rate of change. If I have y equals x squared, I first of all notice I have an exponent on my x, so this is not linear. It does not have a constant rate of change. Let's look at a few graphs. So, I have a few graphs here, and we're going to see. This first one, it's a straight line, so it is linear. My second equation has a couple curves, so it is not a straight line, so it is nonlinear. This last one is made of 2 straight lines, and it has a corner in the middle. Does the rate of change stay the same throughout the whole function? My answer is no. It's a positive slope here and a negative slope here. So this is nonlinear because it has a corner. Linear functions cannot have corners. Corners show that the slope changes. So we have 2 accounts, and they each earn different types of interest. The table shows the balances of each account for 5 years. We are going to graph and compare the data in the table. So we can see the years, we have account A and account B. Now I'm going to graph them with years on my x-axis and the different accounts, the amounts, going up in my y-axis. So when I plot those two, I put this little break here to show that I'm jumping up to 100, and then it moves at a steady interval there. And I can plot account A in orange and account B in teal. So now I can look and see. The points for A make a straight line, and it has a constant rate of change. Each time increases by 10. Points for B do not make a straight line. It starts to curve up here. And it does not have a constant rate of change. Increases by 10, then 11, then 12, and so on. So we can say A is linear, B is not linear.